Good afternoon, everyone. Today, we Group 5 is presenting our project, which is Multiple Player Quiz Game Machine. As we all know, quiz game is a form of entertainment often used on radio or television in which the member of a panel compete in answering questions. In this project, we have brought up a 4-player quiz machine in where each can participate in quiz and judges can evaluate their performance and provide scores. The main feature of our quiz machine are shown in the above slide. We have used a buzzer circuit so that player can race to answer questions by pressing buzzer button. Only the first player to press the button is displayed in the 7-segment display. Then we have also included reaction timer which can count how much time required for a participant to press the buzzer after the question has been displayed. A countdown timer is also used so that we can limit the time of answering session up to 10 seconds. Then we have added question answering module where we kept two options for participants which they can choose. Judges are able to set the correct option beforehand. Finally, there is a score counting module which can up count for correct answer and also it can down count for each wrong answers. Components we used in our project are basic gates, 555 timer, counter, decoder, priority encoder, and marks. Besides, we have used LEDs, 7-segment display, buzzers, switches to take input and show the output.
For the two timers, we need a clock pulse that will be fed to the counter. We use 555 timer to generate a 1 Hz clock pulse. This part is implemented in hardware only. In Proteus, a pulse generator is used. For the score counter circuit, an up-down counter IC is used. If the player answers correctly, then the up-down bar pin will get connected to 1, otherwise 0.
Now let's see how the buzzer circuit is implemented. As buzzers are some kind of push button, we had to latch the circuit. We used SR latch for this. If one player pressed the button, we had to turn off the other player's buzzer input. For this, we used NOT of the other's latched output and end it to the that player's input. So this is the circuit diagram of that. So this part is where we show the Proteus simulation. Here is the buzzer for the 4-player. This is our manual reset button here, this one. And this part is where whenever 9 seconds is detected on the display, the whole system get resetted, which is used as a 9-second limiter. But for some unknown reason, this part doesn't work in Proteus but works fine in hardware. This display shows us reaction time. This part is point counting. Now let's run the simulation. Let's say the host asks the question and the third player presses the buzzer. So it's counting down time. Whenever he answered the question, we have to reset it manually. So the buzzer button is so let's reset it. The whole system get reset. Let's say, and for another run, the host asks the question again, and the second player press the buzzer. So the other player buzzer won't work anymore. It still shows 2. Now for the counter part, this is our counter. If you set 1 here, it will do up counting. So the point is increasing. If we have the low side, say 0, then it will down count. So for the right answer, this part will be connected to high ground. For wrong answer, this part will be connected to ground. This part is a little bit different on the hardware part because we couldn't find this TPST momentary switch. Next is the user manual of the hardware. Here is the player's buzzer button. Here is our main reset button. And the other button is shown in the picture and described in the hardware simulation.
Start.
Now we will show the different blocks of our project. Here we can see the different blocks of our project. 4 players can participate at a time using this machine. Here is the first power supply block. For constant 5-volt power supply, we have used Arduino here. The Arduino is powered by a power bank. Only 5-volt and GND pin is connected from Arduino. None other pin is connected from Arduino. Here we can see only power supply pin are connected from Arduino. Now then we will go to answer option setter block. Here in this block the host will set 2 buttons for wrong and correct answer. That means the quiz question has 2 options of answer. If player press the correct button of answer, here a green indicator light will light up. Otherwise no light will be glow. Now we will go to the block that player who press the buzzer first. Here we can see that there are four player options. The first a small sub block, they are for 4 players, 1, 2, 3, 4. Here are 4 SR latch switches for 4 players, 1, 2, 3 and 4. Here we can see the buzzer button. When a player presses the buzzer first, other player's buzzer will not work anymore. If other 3 players press their buzzers, nothing will be changed. Here 4 LEDs are used to indicate which player has pressed first, and also this 7-segment display is used to show the player number who has pressed first. Besides, buzzers will make sound when a player will press the buzzer. Now there are 2 time counter circuits. One is the reaction timer, another is the answering time limiter. Now first we will go to the reaction timer block. After asking a quiz question by the host, this timer will be started to count the time up to 10 seconds. In the meantime, if any player press the buzzer first, the display will be paused at that moment, and this is our reaction time. At the same time, this 7-segment display will show the number who has pressed the buzzer first. Next, we will go to the answering time limiter. Another 7-segment display will start time counting when the player will press the button first. This time counting allows the player to give answer within the 10 seconds. If any player cannot give answer, the 7-segment display will count up to 9 and then will be reset. If player can give answer, the host have to reset the counter display, and then the host will increase or decrease the point of the player in the score counter board. Here is the marks counter board. We have implemented this marks counter only for single player. For other 3 players, this block will be repeated. In this section, we have used up down binary counter. For correct answer, the host can increase the point by 1 or decrease the count by 1 by pressing the push button here. The player who achieves the highest point will be winner of the game. Thus, the quiz game will go on until a player becomes winner first. After asking question, the counter has start counting up to 10 seconds. Say, within the time a player has pressed the buzzer first, that number will be shown at display and other player will be blocked. Simultaneously, the reaction timer will be paused and answer time counter will be on and counts up to 10 seconds, which permit the player to answer the quiz within 10 seconds who has pressed the buzzer first. If the player can answer correctly, points will be added to the score counter.
Point adding, point decrease. Here is 2 question. Let's say this one is the correct answer selected by the host, and player will press these 2 buttons. So this is the right answer. For this, the light lighted, and for the wrong answer, the light doesn't lighted. And let's say this one is the right answer. So for this push button, light is lighted, and for this push button, light won't work.
Say question is asked and the reaction timer has started its countdown. Then the player 2 has pressed its buzzer, and we can see the number in the display. No player can change this position, and answering time limiter will be reset if any player cannot give answer within due time.
Future improvement. So there is our full simulation of the project. We used a basic SR latch circuit. For improvement, JK latch can be used. Flip-flop IC can be used instead of SR latch. Also, we didn't get enough time to figure out a way to implement an automatic point counter as soon as the player answered the question. Compact PCB design, so this part needs some improvement too. Thank you.